I welcome you to the organic chemistry class. Today we are going to see this organic compounds containing nitrogen. Under this heading we have three subheadings. One is nitrobenzene. Nitrobenzene, a benzene molecule containing a NO2 function. Such a compounds are called nitrobenzene. Okay, single compound. Second one is a aniline. Under this actually amines may be taken. A broad introduction to the first primary, secondary, tertiary, but main compound is aniline. Aniline is a benzene once again containing a NH2 function. And the third one is a benzene diazonium chloride. Benzene diazonium chloride, or commonly you can take it as a diazonium salts, and their uses in the industry, synthetic organic. These three molecules we are going to concentrate, how these compounds are prepared, what are the main important the properties and so on. Let us take first nitrobenzene. Nitrobenzene has a common name also called of oil of myrrhine. Oil of myrrhine. It's a yellow viscous liquid, resembles like vegetable oils, therefore it is also called as a oil of myrrhine. How this compound is prepared? There is only one method for that, is you take benzene and nitrate it. This is already we have covered under the benzene chapter. Take a concentrated HNO3 is the reagent, plus concentrated H2SO4 as a catalyst. Both should be mixed 1:1 ratio outside, because when you mix these two acids temperature is produced, so that hot solution is cooled to the room temperature, then go on add to the benzene drop by drop, maintaining around 60 to 70 degrees centigrade. The temperature is very must crucial here, because beyond the 70 if you go, the product formed nitrobenzene once again undergoes reaction, gives a dinitro product. So therefore the maintaining the 60 to 70 degrees is a must. So nitric acid OH and the H is eliminated as a water. Sulfuric acid is only a catalyst. So that we have seen the reaction of the how this these two reacts and it gets a NO2 plus is the attacking species. This attacks as an electrophile. The reaction happens to be a electrophilic substitution reaction. All the characteristic features of electrophilic substitution will be there, and this is a nitrobenzene preparation. This is the only method and the easier method for the reaction. The other methods is not much suitable. However, in the properties, the properties of this nitrobenzene is also, the one important property is a reduction of nitrobenzene. Okay, this is very important, and several times questions have been asked under this reduction of nitrobenzene. Reduction of nitrobenzene, specifically in different media, that is specially with reference to the acidic medium, neutral medium and basic medium. So we have here 5 reactions, fundamental reactions are there. The nitrobenzene can be reduced into 5 different types of the products. All are nothing but the reductions. Three reductions are the acid base neutral mediums actually. One is a hydrogen and nickel. This is called a catalytic reduction. catalytic reduction. All are reductions I am drawing here. Using hydrogen nickel, the nitrobenzene converts into the aniline. NH2 means aniline. Aminobenzene or aniline. This is the most simplest form of the reduced form. The same you also get in the HCl in presence of zinc. Zinc is a metal, HCl is strong acid, acid and active metal, and the acid will react and forms zinc chloride and produce the nascent hydrogen. Okay. So, the reaction is actually with the nascent hydrogen reaction taking place, and this medium happens to be zinc is a weak base, HCl is a strong acid. Overall, the medium is acidic in nature. This is acidic. So, question may be asked, in acidic medium if it is reduced, what happens means same aniline comes. Benzene with the NH2, that is same aniline comes. So, either with the catalytic reduction or with the acidic medium reduction, same product is coming. The third one type is you are taking a zinc is a slightly weak base. Now, to compensate, we have a reagent ammonium chloride. Ammonium chloride, when you add it to water, it is slightly acidic. This is slightly basic. Net result is a neutral one. So, therefore, the question can be asked, in the neutral medium if you reduce, what happens? The reduction here, what is happening is, in the nitrobenzene, 2 oxygens are removed. In that place 2 hydrogens are coming. That is called total reduction. If out of the 2 oxygen only 1 oxygen is reduced, then what happens? Half reduction is taking place, right? So, that is what happening here. See, 1 oxygen still is there. This product is called a phenyl containing hydroxy containing ammonia. This is called N-phenyl hydroxylamine or phenyl hydroxylamine. The product is known as phenyl hydroxylamine. Phenyl hydroxy ammonia, commonly called phenyl hydroxylamine. This is acidic, this is neutral. Now, we are going to have a basic medium. In the basic medium, zinc you can have a common metal. You too can use some other metals also, but let me use zinc, all zinc you can remember easily. Here HCl, strong acid, weak acid compensated. Now, you can use sodium hydroxide. See that zinc is weak base, NaOH is also a base. 2 bases we are using. Still the zinc reacts with NaOH and liberate the hydrogen, that will reduce this compound to a, this is a benzene with NN, here 1 hydrogen, here 1 hydrogen. This compound is known as a hydrazobenzene. Hydrazobenzene. Lastly, we have a nitrobenzene reduction with the lithium aluminum hydride. Lithium aluminum hydride is a metal hydride. It is a metal hydride. Okay, a metallic hydrides are metal hydrides. Metal hydride, when you are using, the reduction will be in a different way. Here you will get benzene with a nitrogen with a double bond with a nitrogen, again a benzene. 2 benzene with NN. This NN function is called azo function. So, here this compound is known as azobenzene. 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 Now, see the last 2 products, azobenzene, and this one is a 2 hydrogens extra, therefore, it is called hydrazobenzene. This is azobenzene. In fact, this azobenzene to hydrazobenzene you can convert. Add 1 mole of hydrogen in presence of any catalyst like nickel. Slowly, this hydrogen, the double bond will get reduced to NH. Okay? Now, you too can remember how this hydrazobenzene is formed means the aniline and this one eliminates water like this. If the acid medium or catalytic medium formed aniline and that phenyl hydroxylamine eliminates HOH, what comes? NH comes. So, the hydrazobenzene is formed by elimination of water in between these 2 products eliminate water, you will get the hydrazobenzene. I will repeat once again. Remember all these 5 different types of reductions, but the first 2 are the answer is same, that is acidic medium and catalytic hydrogenation, the answer is there, same answer, aniline. Neutral medium, phenyl hydroxylamine. Basic medium, hydrazobenzene. The last product is azobenzene. In fact, azobenzene can be reduced to hydrazobenzene. The most reduced form is among these 2 is hydrazobenzene. With single benzene, this is the most reduced form, aniline, isn't it? So, if you can remember these 5 different reduction mediums, almost every alternate year you find one question on the nitrobenzene reduction. One question every alternate year, definitely one question will be there on the reduction of nitrobenzene. So, which of the following will not give a so and so compound, or will give either the reagent oriented or the product oriented? The question will be a definite question. Reduction of nitrobenzene in different media, especially these 3 medium, that is acidic medium is zinc and HCl, neutral is zinc and ammonium chloride, freshly dissolved prepared ammonium chloride is slightly acidic, and the zinc is basic, slightly basic, weak base and weak acid get neutralized. So, solution acts as a neutral. So, therefore, the half reduction is taking place, right. So, this is the reduction of the nitrobenzene. Now, let us go for the second property of the nitrobenzene. Nitrobenzene, if it is further electrophilic substitution reaction, if you do any reactions, nitrobenzene is a nitro group is a minus a mesomeric effect showing. It shows a minus I effect and also minus M effect, 2 effects. Minus I means through bond electron density withdrawing, minus M means through the resonance it is withdrawing, like this. Okay. So, you will get a plus and plus and plus in the resonance structures of nitrobenzene. Ortho and para and ortho reactions are taking place. Any electrophile, let us say NO2 plus. How to get NO2 plus? Just now we have seen concentrated nitric acid and concentrated sulfuric acid, mix it outside 1:1 ratio, then add it, you will get NO2 plus. This NO2 plus is supposed to attack at and the benzene, but unfortunately at ortho, para and ortho you cannot attack, because already they are also having a minus plus charge. On the O you will have a minus charge. Therefore, where it will react means it will react at either at meta and meta. So, therefore, if one nitro introduced benzene means nitrobenzene containing already original nitro. This is called meta dinitrobenzene. Beta dinitrobenzene. The reaction is when compared with benzene 2. When you take benzene and nitrate it, compare this versus this. This is a somewhat easy reaction when compared with this one. The effect is you are explaining the NO2 is a strong withdrawing group, therefore deactivate the ring, therefore rate of reaction for the nitrobenzene nitration is difficult when compared with the nitration of the benzene. So, therefore, and where it goes means it goes to the meta. So, therefore, simultaneously in this reaction you are observing the 2 things. Compare the nitration of benzene versus nitrobenzene. Nitrobenzene nitration is difficult. Therefore, we are saying this NO2 is a ring deactivating group. When compared with benzene, benzene only hydrogen is there, here NO2 is there, minus M groups are strongly withdrawing, minus I combination. So, the strong withdrawing group, therefore, ring deactivation. That is why rate of reaction of the nitrobenzene or further nitration of nitrobenzene is difficult. Second point is where it goes. It goes to the meta position or third position and fifth position. If you further nitrate it, it is much more difficult. Here the temperature is 60 to 70 degrees is enough. Here beyond the 70 you have to use it. Further nitration, probably beyond the 100 degrees you will get a trinitrobenzene, but that is a trinitrobenzene is an explosive. Therefore, in the laboratory it is not advisable to prepare, because once the compound is formed, starts explosion means it is not in our control. The second compound also dinitrobenzene, nitrobenzene, both will be advisable to do in the laboratory. So, here electrophilic substitution, one of the best electrophilic substitution here is nitration of any reaction, however you can do, but only thing is in some books it is also specially mentioned Friedel-Crafts acylation. Friedel-Crafts acylation, that is using the anhydrous aluminum chloride. If you do this, supposed to get a acylated nitrobenzene, the reaction will not take place because the acyl group happens to be a very weak electrophile and this is a strong deactivating, therefore reaction taking. Otherwise, bromination, chlorination, nitration, alkylation and the sulfonation can be somehow you can do it, except this Friedel-Crafts acylation. All the 5 reactions of benzene successfully you can do it. Now, let us go to the second compound, that is aniline or amines. Aniline is our focused compound. Aniline is nothing but a benzene with a amino group. Aminobenzene is the aniline. But let us also have some points on the amines. What are these amines? Amines are the ammonia derived compounds are amines. We have 3 types of the amines. If 1 R is there in the ammonia, it is called 1 degree amine. 1 degree or primary amine. Primary amine. If 1 alkyl and rest 2 hydrogens are there, such amines are called 1 degree amines. If 2 R's are there, only 1 H will be there, that is called 2 degree or the secondary amine. 2 alkyls, 1 N, 1 H. If 3 R's are there, no hydrogen will be there, such amine is called 3 degree amine. 3 degree amine or tertiary amine. In fact, you too can have a 4 alkyl groups. When 4 alkyl groups are there, N will have a plus charge, outside some X minus, either hydroxide or a chloride, sulfate, nitrate, any anion can be there. Such amines are called 4th degree or quaternary. Quaternary, but they are not amines, they are ammonium. If it is Cl, ammonium chloride, okay, like that, salts there. Quaternary ammonium salts also there, but they are not showing their ionic compound, therefore they are highly soluble in water, their reactions will be different, they are not following the amines properties. In the amines, the basicity comparison is the one of the important question. Ammonia is originally base. In the inductive effect interaction also we have seen this. Ammonia can donate electron pair to the H plus. H plus is an acid, so therefore this is a base and you will get a NH4 plus. So, an electron pair donor is base, acceptor is acid. So, ammonia is originally it has a character of donating electron pair, therefore it is called a base. But however, when alkyl group is there like a methyl group or ethyl group, now this ammonia acts what type of base it is? Alkyl group is a carbon attached, so nitrogen is more electronegative, therefore it pulls a small electron density through the bond. The alkyl group happens to be a plus inductive group and NH2 supposed to be a minus I group. So, alkyl group, whenever alkyl group that is plus I group is attached, these amines are stronger amines. Stronger amine when compared with ammonia, okay. They are also actually they all organic amines are bases, weak bases. But when compared with ammonia, if I term as a base, compare the ammonia with methylamine. Methylamine is stronger amine than this one. Similar the way, if 2 R's are there, okay, if 2 R's are there, then naturally 2 plus I affects a more stronger one, okay, relatively than this one, it is a more stronger base. The theory can be extended to the tertiary amine, that all the 3 alkyl groups when they are donating, it should be the much more stronger, but unfortunately what happens when 3 alkyl groups comes from all the 3 sides, it closes the entry of proton or approach of proton, therefore many times tertiary amines, due to the phenomenon called the steric hindrance, they are having a less basic than the 2-degree amines. So, one can say among the, when R is equals to CH3, when R is equals to CH3, you can say the 2-degree amines are more basic than 1-degree than the simple ammonia. This is the order. Okay. So, the amines are alkyl substituted amines are stronger amines. But when come to the aniline, lone pair is there on the nitrogen, it is donating. Therefore, phenyl group acts as a minus M group. So, when plus I group is attached, we are saying increasing the basicity. When minus M group is there, what type of the basicity means? It is a very, very weak base, weaker base. So, therefore, aliphatic amines, aromatic amines, if you compare, methyl amine is the overall order may be written like this. Methyl amine is a stronger base than the ammonia. Ammonia is stronger than the aniline, because in the aniline we have a minus M group, in the methyl it is a plus I group. So, plus I group increases the basicity, minus M group decreases the basicity. Therefore, overall order are the comparison of aniline versus ammonia versus methylamine. Methylamine is stronger base when compared with ammonia. It is also to correct that a methylamine will be too many times, ammonia is too many times greater. Reversely, the aniline is too many times weaker because it is a mesmeric effect. The electrons are totally from the nitrogen, it is withdrawn. So, therefore, the donation of the nitrogen to that electron pair to the proton will be almost, it is the decreased. So, therefore, you can say the aniline is too many times weaker than the ammonia, also correct. Now, going to the what are the how this aniline is prepared with reference to the aniline, because we do not have all the amines and all that, but with especially we are point out this preparation of aniline, how this aniline is prepared. The one easy method just now we have seen from the nitrobenzene, reduction of nitrobenzene, phenyl NH2, let us call it NO2, phenyl NO2 is nitrobenzene. Nitrobenzene, when you reduce either with the two methods we have seen, one is hydrogen and nickel, that is catalytic reduction, or with acidic medium, zinc and HCl. Both the methods will give the aniline. Nitro group is reduced to NH2, aminobenzene. This is the one simple method. So, reduction of nitrobenzene gives the aniline. You have some substitution methods also. Substitution methods. In this methods, you can take a chlorobenzene or phenol, for example. A phenol, the OH group can be replaced by amino. You take ammonia, the ammonia will replace the OH group and you will get the zinc chloride on heating around 300 degrees centigrade. This NH2 will replace this one and you will get the aniline. Or the substitution methods, you can have one more example, a chlorobenzene. Actually, in the case of aliphatic, if RCl is there, methyl chloride, in preparing methylamine is very, very easy. But in aliphatic case, ammonia replacing is also not that easy, but with a catalyst like a copper oxide heating around 200 degrees centigrade, this lone pair will replace the Cl and you will get the aniline. So, these two methods of the substitution methods and one reduction method is the suitable for the aniline preparation. Now, let us go for the properties of this aniline. First property is basic property. That is why when aniline is treated with HCl, immediately aniline is actually insoluble in water, H2O. But when you add dilute HCl, it is soluble. Why it is soluble means it reacts with HCl, forms into a NH3 plus a Cl minus a salt is formed. That is why soluble in water. So, only aniline if you add water, it is not soluble, though it makes hydrogen bonding also because of the benzene big molecule, it dominating aromatic character and organic character, therefore, it is not soluble. But the moment when you add a dilute HCl, it reacts and makes a anilinium chloride. This is called aniline, just like ammonia plus HCl, ammonium chloride. Aniline plus HCl, anilinium chloride is formed, which is a salt, therefore, it dissolves in water. So, this is the one wonderful character. So, in which it is readily soluble, dilute HCl. So, separating methods also in the practical chemistry we will see. If aniline and benzene is there, how do you separate? Add dilute HCl, shake it well. So, aniline comes into dilute HCl, separate it, afterwards you add dilute sodium hydroxide, HCl is nullified, again aniline will be regenerated, right? Nothing. So, then let us go for the other properties. Aniline undergoes one specific reaction called with nitrous acid, HNO2 reaction. This is called nitrous acid. Nitrous acid. This acid happens to be it is a differentiating also. In the syllabus it is mentioned how this 1 degree, 2 degree, 3 degree amines are differentiated. Let us have the not only aniline, we also have the other reactions. Let us take aniline is a 1 degree amine. As a 1 degree amine, we take it. This is a 1 degree amine. If you take on the aniline, on the NH, if you have a 1 alkyl group like a methyl is there, this becomes what? 2 degree amine, right? If it is a 3 degree amine, 3 degree amine will have a 2 methyls. This is a 3 degree amine. How this 3 degree amine, 2 degree amine, 1 degree amine differs with nitrous acid? All these three you add the same night. Unfortunately, nitrous acid is not available in the market because it is unstable one, but you can generate when you add NaNO2, it is a solid dissolved in water, add HCl freshly, then this mixture will generate the HNO2. HNO2 will contain a NO group and OH. This HNO2 attacks on aniline, gives a reaction in which this NH2 is converted to N double bond NCl. This is called what? Benzene diazonium chloride. Benzene diazonium chloride. What is the feature of this benzene diazonium chloride? It is a salt. It also exists like this. A phenyl with a N triple bond N plus and Cl. Salt like. That is why highly soluble in water. And this N2 is a strongly withdrawing group. Therefore, a small temperature if it is available also N2 will go out, you will get phenol. So, therefore, the temperature must be controlled. It is 0 to 5 degrees centigrade is maintained. In fact, it is not heating, it is cooling we are using a freezing mixture. If you cool this aniline and then prepare this solution add it first HCl to aniline, then you add sodium nitrate, you will get a red colored benzene diazonium chloride. This is having a orange to red colored solution it is. Then see that secondary amine also you add the same thing, same reagent. That is sodium nitrate HCl when you add this HNO2, the OH and H will go out as a water, NO group enters onto this. So, what happens this benzene, I will write phenyl, phenyl on the N you will get a N double bond O group, right. There is no much change in the structure, this phenyl I have written as a PH, on the N H is gone, NO has come, this product is called N-nitroso, N-nitroso. So and so, the same name N-methyl amine, that N-methyl amine you have to write. N-nitroso N-methyl amines are yellow colored oily liquid. So, color is the important, yellow color you will get, an oily liquid is formed. In the 3 degree amines, same reagent when you add, there is no chance of entering NO onto the N also because there is no H now. So, NO enters into the para position, that is on the top this you have a N with 2 methyls, on the bottom that is on the 4th position or para position NO group comes. These products are called para-nitroso derivatives. Para-nitroso so and so, the name will be called para-nitroso derivative. These products are called green in color. So, therefore, one can easily identify whether the given amine is a 1 degree or 2 degree or 3 degree. If it is aliphatic, in the aliphatic case of 1 degree amines, the reagent will give the alcohol is formed, same reaction, but the nitrogen gas is evolved. 2 degree same. 3 degree aliphatic, that means R3N if you take, you get a solid is formed, white solid is formed, no yellow, the green coloration is formed. Therefore, only the secondary 2 degree also will give the same reaction like aromatic. So, you cannot differentiate the aromatic secondary and aliphatic secondary, same yellow colored, yellow product. So, these two will be common, but in aliphatic aromatic, aliphatic amine is nitrogen gas liberation, aromatic amine is red color, aliphatic tertiary is solid formation, aromatic tertiary is green. So, therefore, aliphatic aromatic also you can differentiate, or within the aromatic within the aliphatic also you can differentiate. This nitrous acid reaction also several times asked in the EAMCET examination. This is a differentiating reaction and also very important reaction, because we have a continuous, and the third compound is diazonium chloride. Where from it is prepared? From the aniline. Aniline diazotization, 1 nitrogen becoming 2 nitrogen. Therefore, the reaction is also called a diazotization. Azo stands for the nitrogen. 1 nitrogen becoming 2 nitrogen, diazotization. Diazotization reaction means nothing but the getting the 2 nitrogen compounds from the 1 nitrogen compound. Aniline undergoes some electrophilic substitution reactions, but not all electrophilic substitution reactions. Under this, only halogenation is perfect. Halogenation with chlorination and bromination is perfect. Fiddlecraft alkylation, acylation, failure reaction. Nitration sulfonation, because acidic medium aniline undergoes a protonation, therefore deactivation fails. Fiddlecraft alkylation, acylation, when you do that, reagent attacks on the nitrogen, gives a analkylation and acylation, that will take later. This under this halogenation, one of the important reaction is aniline you take, add bromine water or bromine acetic acid. Bromine acetic acid or water, when you add, tribromoaniline comes. Where these bromines will come means aniline is a activating group, ortho, para, ortho. In the resonance structures you will have a minus charge. Therefore, the groups will come at ortho. So, orthobromoaniline, you also get a bromine at para and also at ortho. So, therefore, you have to say this one as a 2,4,6. 2,4,6 are ortho, para, ortho. This is also called a symmetric tribromoaniline. Symmetric tribromoaniline. Symmetric means with reference to this one bromo, other bromines are equally one third they are arranged. Therefore, symmetric tribromoaniline is formed, which is a white color precipitate. The moment you have a reaction, you will get a white color precipitate. So, this can be used the identification test also. So, the only halogenation, that to bromine is an excellent reaction. The remaining other 4 reactions are failure, but one of the reaction you code here, N-alkylation and N-acylation you can have. N-alkylation and the N-acylation. What is this means? You take aniline. If you treat actually on benzene, if you use RX and aluminum chloride, alkylation takes place in benzene. But here, a lone pair on the nitrogen is very much reactive and it is an electron donating. Therefore, if you do alkylation, alkyl halide like methyl chloride example. So, the methyl chloride, the methyl group attacks on the N. So, therefore, what happens? The N will going on methylated. The subsequent reaction NN dimethyl. First 1 degree amine has becoming into 2 degree amine. Subsequently, it will become NN dimethyl amine, that is a tertiary amine is formed. Similar the case, if you do acetylation, RCOCl also, you will get a RCO plus is generated, which instead of attacking at the ring, because N is very much the attacking that is susceptible for the reaction, you will get the N lone pair, on the lone pair NCOCH3 comes. However, only one acylation taking place, subsequent acylation is not a successful reaction, because when once the CO group enters, the lone pair is also withdrawn by the CO. It will become less active. That's why second steric hindrance also one of the reason, but acetylation, if you do only N-acetylated product, N-diacetylated you don't get. Alkylation, alkyl group as you increase, the lone pair will become much more rich, therefore second alkylation also easily. And if you compare also, here it is normal, it is much more easy because it is an alkyl groups donating, so the rate of reaction increasing. Here the after one step the acetylated aniline will be reaction is, you get a reaction stops here, you can find the no reaction in fact. So this reaction also several times asked with with reference to the specific examples like CH3COCl. This is called what? Acetyl chloride. Acetylated aniline comes. That is NH C double bond O CH3. This is called N-acetyl aniline is called acetanilide. Acetanilide. A common name it is. You can call it as a N-acetyl benzene. Instead of the acetyl chloride, you can use a benzene COCl. This is called benzoylation, not benzoylation it is. This is a acetylation. So with benzoylation, the Cl and H will go, benzonylide comes. Already a big benzene NH is there, and a C double bond O, again a benzene will be there. This is called benzonylide. A common name. You can call it as a N-benzoyl aniline. N-benzoyl aniline is commonly called benzonylide. Benzonylide and acetanilide both were asked in the previous IIT question, this EAMCET question papers. Now let us go for the one more compound, that is benzene diazonium chloride. Benzene diazonium chloride. This topic is recently introduced. I think majority of the books are not giving the much details on this, and we don't have any previous questions also on this topic. However, in the aniline it was a question, when aniline is treated with nitrous acid, that is HNO2, benzene diazonium chloride comes. So its structure is a benzene with the N double bond NCl. It has a polarized structure. Cl minus, if it comes, a lone pair comes here and Cl goes out. So therefore you too can have another structure like this, a benzene with N triple bond N plus and Cl minus. A salt structure or a molecular form both exist together. That's why the N is a very good outgoing group also, and a new group incoming will become possible. So benzene diazonium chloride, how it is prepared? The preparation is you take aniline at the nitrous acid, that is NaNO2 and HCl. At 0 to 5 degrees centigrade, you will get the benzene diazonium chloride. If the temperature is increased, you will get the aqueous solution will replace this, and you will get a phenol product may be formed. This is the one single preparation you can. But we have a huge number of the synthetic applications are properties, are all the properties of the diazonium chloride are nothing but the synthetic applications in fact. Synthetic applications, or you can have all properties are nothing but these applications. Properties of phenyl N2Cl. See some of the reactions I will give here. The first one is benzene diazonium chloride. When treated with CuX in presence of HX, in fact the other way is more correct. You take the HX is the reagent, and in presence of CuX. So the X has got a chance now. X can be a chloro minus, Br minus, or even cyanide minus. Actually, these two are halides. This is not halogen. This is called pseudo halogen, which follows the halogens the footsteps. So this is called pseudo halogen. All this one X can be one of this can replace the whole product, and you will get this X containing benzene. This is a well known reaction called what? Sandmeyer reaction. Sandmeyer reaction. A name reaction. So what is Sandmeyer reaction? It is nothing but a preparation of a X substituted benzene from the benzene diazone. What is X? X can be chloro. So the chlorobenzene comes, bromobenzene comes, cyanide benzene comes, right? Now when once you get the cyanide benzene, it has some more applications. A cyanide is a group which can give the two important derivatives. If you hydrolyze with H3O plus, acidic medium or basic medium, you will get a benzoic acid. So one can ask, how do you prepare the benzoic acid from aniline? Aniline to you use HCN. X is equals to cyanide, it's copper cyanide. So cyanide will come, that you hydrolyze it, or reduce with hydrogen nickel. What comes is C will become CH2, C will become CH2, N will become NH2. This is called benzyl amine. This is called aliphatic one, benzyl amine. So this is a wonderful question. Now, how do you convert this? How do you prepare? This is prepared from the aniline. So aniline to diazonium chloride, you know, nitrous acid addition. So question can be asked from aniline to benzyl amine. In between a CH2 group is, have you got it? First you convert into diazonium salt, prepare a cyanide, and the cyanide is reduced with hydrogen nickel, you will get benzyl amine. This is a wonderful application. The Sandmeyer reaction was improved by the another scientist called Gutterman. Gutterman reaction. This is improved Sandmeyer reaction. Here the copper chloride is a +1 oxidation state, very labile one. It is preparation itself is a tough one. So what he has taken is, you take N2X, where X is given a chance for you, chloro or bromo or cyanide, all may be anions. Now this you just add a copper powder. If you want a bromide, while you are treating aniline to diazonium chloride, instead of HCl, you take HBr, you will get a bromo, diazonium bromide. Copper powder, heat it, you will get a bromo or the X containing compound. So little short method it is, okay. Its reaction has become less complicated. Only thing is, how to get this X means, instead of here NaNO to HCl, right, we have used HCl. Instead of HCl, you use HBr, you will get a bromo one. The bromo one, copper one, bromobenzene comes, okay, like that. This is a Gutterman halogenation reaction. Then with water, just boil with water, phenyl N2Cl, just boil with water, you add water and boil it, you will get the phenol. This is one commercial method for the preparation of phenol, because introduction of OH into the ring is a tough one. OH is a -1, directly cannot, only electrophilic substitution is ready. But this nucleophile, how to introduce means, prepare a nitrobenzene, reduce to aniline, diazotize it, boil with water, you will get phenol. That is one of the commercial method for the preparation of aniline. Then the fourth method, you can introduce groups like fluorine. Fluorine introduction is known as a Schiemann reaction. Schiemann reaction. The syllabus is introduced recently, this one. So there you may not find in the old questions this question. What is Schiemann reaction? Introduction of fluorine. Diazonium chloride, N2X, you take a chlorobromide, what is not necessary. So diazonium halide, or you take a chloride specifically, doesn't matter. But you add the BF3, boron trifluoride plus HF, hydrofluoric acid, and BF3. These together will react and forms the H plus and BF4 minus. This BF4 minus replace this N2Cl. Temporarily you find a N2 plus BF4 minus. This salt is formed. The salt on slow heating, this decomposes, BF3 will go, N2 will go, fluorine comes. So the fluorobenzene, fluorination of benzene is an explosive reaction. However, through this method, you can prepare a fluorobenzene. Fluorobenzene. Similarly, iodination, iodobenzene can be subsequently, you can prepare with an aqueous solution of potassium iodide. If you add, iodobenzene comes. Okay, iodobenzene comes. All these are replacement reactions. In addition to this replacement reactions, we have some coupling reactions also. Coupling reactions. Two types of coupling reactions you can find, either with phenol or with aniline. Aniline or phenol you take. If you take phenol, the phenol you take in 10% NaOH, dissolve in the NaOH, this phenol, then add this benzene diazonium chloride. This N2Cl will couple at the back side of this phenol, N. So, the whole group will come here, a phenol will be there as it is, but this whole group will couple back side. This is an azo dye. Dyes means it is a colored compound which is used in the textile industry permanently. It gives a color for the fabric. Similar the case, the reaction will give a, only thing is instead of 10% NaOH, you take a dilute HCl and dissolve it. In dilute HCl, dissolve it, then add the benzene diazonium chloride, N2Cl. You get the similar type of product, because amino group is also very strong activating. So, therefore, a weak diazonium benzene can come into the ring. This is also a very good red colored azo dyes. This is a coupling reaction. Lastly, we have one or two reduction reactions of diazonium chloride also. Diazonium chloride can be reduced with two different types of the reactions. If you use a stannous chloride, SnCl2 and HCl, the compound is formed into a benzene with NH2. Here the nitrogen is not detached, just converted into the phenyl hydrazine. It is a weak reducing agent, phenyl hydrazine. Whereas if you use a strong reducing, that is like tin and HCl, nascent hydrogen will come and forcefully reduce, and you will get two pieces. One is aniline, the other one is ammonia. However, both will be in the form of, because HCl is there, both will be in the form of salts. Because HCl will add with aniline, HCl will add with ammonia, you will get anilinium chloride and ammonium chloride, salts will be there in the mixture. But what is the product means? Aniline and ammonia, the cut N bond cuts here, and you will get. Otherwise, a weak reduction or a mild reduction will give the hydrazine. Okay, right. Now, some of the questions pertaining to this three topics, let us see. The first question is, the structure of the compound formed when nitrobenzene is reduced by lithium aluminum hydride. I said metallic hydride. Metallic hydride is azobenzene. Answer is 3. The last third one is the answer. Second question, nitrobenzene on reduction with zinc and ammonium chloride. Remember, zinc is a light, that is a weak base. Ammonium chloride, freshly prepared ammonium chloride is because of the cationic hydrolysis, it is a acidic solution. So, the weak acid, weak base, neutral. Neutral medium means, I said it is acidic medium is aniline, neutral medium is hydroxy, that is N-phenyl hydroxylamine. And basic medium is hydrazobenzene. This is the fourth one, N-phenyl or phenyl hydroxylamine is the right answer. Next goes to the third question is, which of the following reactions can produce aniline as a main product? The first one is zinc KOH is a basic medium reduction, hydrazobenzene comes. The second one is nitrobenzene, zinc and ammonium, neutral medium, that is a phenyl hydroxylamine. The third one is the lithium aluminum hydride is a azobenzene. Zinc and HCl is the aniline preparation. Last one is the right answer. Next. Which one of the following compounds forms a quaternary salt on reacting with excess of methyl iodide? That is any amine like phenylene or any amine. If when there is a NH2, if you add a RX, first one R will be coming, R containing the aniline will come, then RR will come, This will become a quaternary, tertiary one. Once again, if you add Rx, what happens? Then R will enter. You will get a 3 Rs already entered, and original one is a phenyl group. Now N will have a plus. This type of the 4 groups contained is called quaternary amine. So this type of reactions you can only do on the amino group. That is, third compound is aniline. Aniline is a primary amine. When you add methylamine, it will become 2 degree, excess 3 degree, excess 4th degree. Quaternary amine can be prepared. Yes, next. Aniline is not a major product in one of the following reactions. Identify the reaction. In the first one, aniline is formed because the phenol OH is a replacement reaction. Second one, nitro with zinc powder, there is no reaction. Zinc powder will not have any reaction. Zinc and alcoholic, this is a reduction. Reduction gives what basic medium? Hydrazobenzene comes. In the third medium, aniline is formed. Fourth also aniline is formed. So 1, 3, 4 aniline comes. Second medium is a reduction of the nitrobenzene to hydrazobenzene. So answer is 2 therefore. Which one of the following is the molecular formula of a tertiary amine? In fact, the question can be asked in a better way. Which following molecular formula fits for tertiary amine? Tertiary amine means a nitrogen should contain 3 Rs. 3 Rs, minimum number of carbons required for this structure is at least minimum 1 carbon should be there, isn't it? So unless you have 3 carbons in the molecular formula, you cannot have a tertiary amine. You can have a confusion is here actually. This is tertiary carbon on which if a chlorine is there. This compound is called tertiary alkyl halide. Tertiary alkyl halide. But tertiary amine is not like that. Tertiary amine classification itself is totally different. See, alcohols, amines and all other compounds, like let us say a nitro compound. Nitro compound, this is a tertiary nitro compound. Because a 3 degree carbon based functional group, if a nitro is there, tertiary nitro compound, a tertiary alcohol, because 3 degree carbon OH is a tertiary alcohol, 3 degree alcohol, and a tertiary chloride, tertiary butyl chloride it is, okay. All tertiary is based on the tertiary carbon is the criteria. Tertiary carbon, whichever the group is there, that compound is tertiary. But a compound like a tertiary carbon on which NH2 is there, this is no more a tertiary. This is a primary, because the classification of amines is ammonia is the compound. If 1 R is there, it is called a 1 degree amine. So when it will be tertiary? When 3 Rs are there. That means 3 minimum carbons whenever it is there. This type of nitrogen in the center, 3 side 3 carbon can be possible. So therefore second answer you see there are 3 carbons. Rest carbon compounds are 2 carbon, 2 carbon, 1 carbon. How can you get a tertiary? So therefore logically the second answer is that fits, because with C3H9, nitrogen in the center, 3 sides 3 methyls. So formula becomes what? C3H9N. So with this you can also write 2 degree also. 2 degree means NH, CH2, CH3. This is the 2 degree one, right? With this you can also write 1 degree also. 1 degree means 3 alkyl groups at a side and 1 NH2. So this formula can be written as 1 degree, can be 2 degree, can be 3 degree also. But other compounds you cannot, other formulas will not fit for the 3 degree compound writing. So therefore second answer will be the right one. Next. Consider the following reaction. A C2H2, it is an acetylene. Acetylene on red hot iron tubes will give benzene. A must be the benzene. Benzene on nitration at 70, nitrobenzene comes. Nitrobenzene with lithium aluminum hydride, that is what azobenzene is formed. So the A and B are the benzene and nitrobenzene. So answer 4 will be the right answer. Right. 8th question. Consider the following reaction. Nitrobenzene tin HCl. Tin HCl is an acidic medium. Zinc HCl or tin HCl will give the aniline. Aniline on benzoic acid chloride, that is benzoylation taking place. So benzoylation will give benzonylide. Benzonylide is nothing but the second answer. Nitrobenzene on reduction with tin HCl gives again aniline. Aniline which on reaction with acetyl chloride, acetanilide comes. Which of the following is B? So acetyl, N-acetyl benzene, that is second answer is the right one. Which of the following is a secondary amine? Secondary amine means it's not all other compounds secondary means if let us say a butane, this is 1 degree carbon, this is 1 degree, in between two carbons are 2 degree, therefore if OH is here, I call it is a 2 degree alcohol, because the classification of alcohol is standard of the carbon, 2 degree carbon OH is 2 degree, but the amines classification is when two R's are attached like ammonia, 2 R's are there, this is 2 degree amine. So, let us find a nitrogen with 2 alkyls, that is the last one you see, one benzene, one methyl is the 2 degree amine. Which of the following reagents converts nitrobenzene into N-phenyl hydroxylamine? As I said, acidic medium is aniline, neutral medium, this is neutral medium is phenyl hydroxylamine, neutral medium you can get a zinc and ammonium chloride. I said ammonium chloride is weak acid, zinc is weak base, net result is a neutral half reduction, that is phenyl hydroxylamine is the answer. No need to by heart, this is biologically you can derive the answer, it is a neutral medium half reduction, that is phenyl hydroxylamine is the answer. Next, by which of the following reactions can one get a N-methyl aniline from aniline? So, aniline to methylation, aniline gets a N-methylation, as we have seen. Aniline undergoes a N-alkylation and N-acylation. Instead of in the ring, the aniline when you treat it with alkyl halide, better is a methyl iodide we use, little costly one, but the reaction is successful. If it is methyl chloride is used, cheaper one, but the reaction will be slow. Iodides immediately undergoes a introduction of the plus, so you will get a NH2 is aniline. So, 1 methyl comes here, this is called N-methylation. One more subsequent reaction, this is already 2 degree, now it is 1 degree, it will become a 3 degree, subsequent reaction 4th degree, salt will be forming. Okay? This is called alkylation on the nitrogen. In the ring it is called Friedel-Crafts alkylation, but on the nitrogen you are getting, so this is called N-alkylation or alkylation. Right, next. Which of the following is not a base? Which of the following is not a base? First one is N2H4 is a amino, that is NH2. Twice NH2s are very good amine, it is a stronger base in fact. Second one hydroxylamine, hydroxyammonia, it is also base. A tertiary amine is also a base. The last one you see HN3, this is not a NH3. So, it is a eyesight, you see NH3 is ammonia having a lone pair, it is a base, but whereas this is not a acid, this is the proton donating acid, N3HR, HN3 is called hydrojoic acid, So, this is an acid, so it is not a base, all 1, 2, 3 are bases, the last one is an acid. Next. Aniline when heated with sodium nitrate HCl, diazotization taking place, you will get a benzene diazonium chloride, second answer is right, diazotization reaction it is. Oxidation of aniline with potassium dichromate and sulfuric. Actually, aniline is very much a ring activated compound, it undergoes a easy oxidation. Aniline has a one, if you use any oxidizing agent, you will get aniline black, a black compound which is used as ink in the several ink pens, but a careful oxidation, it is not said, but it should be a very careful oxidation, K2Cr2O7 in presence of sulfuric acid, very dilute sulfuric acid, dilute dichromate should be taken, then the oxidation takes place here and you will get a parabenzoquinone. Ortho also you will get, but it is a minor product, major one is a parabenzoquinone. Subsequently, it will link with the another benzoquinone and you will get a pink colored substance slowly on exposing aniline. When aniline is exposed to aerial oxidation, it turns into the light pinkish, then chocolate brown, then it will become a dark chocolate and becomes into black. What is that means? It is an aerial oxidation actually. Without any reagent also it undergoes oxidation. Next. Which one of the following is a tertiary amine? Tertiary amine means N should contain a 3 R's. Okay? The word he has used, first one is the tertiary butyl amine. What is tertiary butyl amine? This is tertiary butyl amine. In the name It is tertiary butyl amine radicofunctional name, but it is a 1 degree amine. So, the third one you see dimethyl secondary butyl amine. What is secondary butyl amine? This is called secondary butyl amine, will have a dimethyl. 2 methyls containing secondary butyl amine, N is having 3 R's, therefore it is a 3 degree. So, it is so misleading question it is. Tertiary butyl amine is a 1 degree amine actually. Dimethyl secondary butyl amine is a prime, that is a tertiary amine. Secondary butyl, secondary word is there in the name, but is tertiary. It's a misleading question, but should be subject. If it is you are clear, it you can answer. Third one is right answer. Next, aniline on treatment with bromine water gives white precipitate, that is tribromo 2,4,6 tribromoaniline, is also known as symmetric tribromoaniline. The answer 3 is the right answer. When aniline is treated with chloroform KOH, this we have covered in the chloroform chapter. Aniline, when treated with the CHCl3 and KOH, the reaction on phenol is known as Reimer-Teimer reaction. On aniline, this NH2 group is converted into NC. This is called phenyl isocyanide. CN is cyanide, NC is isocyanide. Phenyl isocyanide. This is also called phenyl carbyl amine. This is also called carbyl amine. Phenyl carbyl amine. The reaction is known as that's why a carbyl amine reaction. Very popular reaction. The formed compound is a slightly poisonous compound. It gives a headache, and the smell itself is a very bad smell, will have a foul smell. In the several reactions, it is described some X compound containing foul smell means immediately you can say it is a phenyl isocyanide. Nitrobenzene with tin and HCl, it is aniline. So, the answer is 2. Aniline is treated with sodium nitrite and HCl at 0 degrees. Aniline is becoming into a diazonium salt, a benzene diazonium chloride. 1 degree compounds will give a red color. The diazotization reaction, that is benzene diazonium salt is formed. I think this is the last question. So, with this we had conclude that the nitrogen containing compounds, we have 3 topics are there. One is nitrobenzene, in which main reaction is reduction of nitrobenzene. In the aniline, we have a basicity is one question, and the 1 degree, 2 degree, 3 degree classification of amines is one question, and also the alkylation, acylation, that is the important reaction. In the diazonium salts, the N2Cl replacement reactions also happens to be very wonderful equations. Hope you have enjoyed the class. Thank you. Next class we will take the polymers. Thank you.